when it comes to capacitors, actually is a combination of two conductors. So use it to store charge and energy. Energy, how it will store? It will store energy in the form of electric field. Because electric field is there between two charge. Example, you might have seen electric field is there. Due to this, whatever charge you keep here, it will do a work, right? So in the form of electric field only, it can store that energy. Okay. Next, experimentally, it is found that Q is proportional to potential difference between the 2 points. Then the Q is equal to, if proportionality, if you remove, you will get a constant that is Q is equal to CV. But you generally will make a misconception that this Q and V, C will depend upon Q and V, but
No.
What factors it will depend upon?
The distance between the plates of capacitor, area of plates of capacitor.
That is for parallel plate, but any other can also be there. Geometry depends upon geometry, and it depends upon the medium between them. Geometry and medium. Okay. So, like example, we can write it as mass is equal to density into volume, right?
Shape, size, and surrounding medium.
So we see shape, geometry, and medium also. So mass is equal to density into volume. So we can write it as volume is equal to mass by density, right? Formula. Volume depending upon mass and density, right?
Volume.
Suppose a container is there, in that you kept a substance, then the mass, if you know the density, the mass of the substance is equal to density into volume. If you do, we'll get the mass of the substance, right?
But density is constant.
Density is constant. Mass is equal to density into volume. We do. If you know the density, you know the volume of the container, then mass of the substance in that container is equal to density into volume. We will write, right? But volume is equal to mass by density. Can we write formula wise? But is this volume depending on mass or density? No, right? This is depending on the container, geometry and shape. If you increase the if you increase the density, mass will increase. If you decrease the density, mass will decrease. That's it. But volume will not depend upon this mass and density, is it? Similar comparison here, capacitance will not depend upon capacitance is equal to Q by V, but it will depend upon Q or V. It will depend upon the geometry and the medium. Okay. Then that is one of the very crucial point you need to understand as a fundamental concept of capacity. Then capacitors are generally mentioned in farads. 1 farad is equal to 1 coulomb per volt. But this is not generally used. It is used in the form of 2 microfarad, picofarad. In that way, they will use. Okay. Then types of capacitor you will find parallel plate capacitor. It is highly important for your exam. Very highly. And there is a spherical capacitor. And there is cylindrical capacitor. Parallel plate capacitor, what you will generally do? parallel plates if I take. One charge is positive here, and negative. We connect this to one. Okay. Now, here actually, there will be an electric field of this sort. But actually, this one also will happen. But actually, this effect will be neglected. You consider that area is much greater than the distance between the plate here. And so the fringe effect will be neglected. Electric field is not constant there, not uniform. For general problem solving, we neglect the fringing effect. The electric field formula. What is electric field formula? Sigma, yeah, right? For conductor.
So conducting sigma by
So can I write it as Q by uh, uh, Q by yeah, sorry, sigma by epsilon naught. Sigma by epsilon.
ah
Sigma by epsilon naught. So then can we write sigma as Q by A and epsilon naught here? Electric field. Between them, electric field is two conductors. Electric field is what? Sigma by epsilon naught is equal to Q by A epsilon naught. Otherwise, understand, matlab, actually that has come from 2 points here.
समझा मैं.
No,
I
no,
got it.
not the way you are thinking. Because in that thinking you have done, here there will be positive charge, right? Because of the two charges, you will have the sigma by epsilon naught there, right? When you take a conductor, you will have one positive charge here, and also there will be a positive charge here as well, right? Because of that, the net will be sigma by epsilon naught there, isn't it? Because this due to this plate, this is sigma by 2 epsilon naught. Due to this plate, this is sigma by 2 epsilon naught, right? But here in conductor, this capacitor arrangement, you will have charge like this. So here, due to this plate, this first plate, second, while I'll take ends 1, 2, 3, 4. First plate, second end is sigma by 2 epsilon naught. Second plate, first end is sigma by 2 epsilon naught. But second plate, first end will attract electric field. That means electric field will be towards second plate. First plate, electric will be away from first plate. So both will add up and will become sigma by epsilon naught. Got it?
No.
Huh?
First plate.
First plate, second plate, electric field, how it will be there? It will be going away from it.
It will be towards that another plate.
Second plate electric field will be towards that field only because negative charge attracts field. So sigma by 2 epsilon naught due to this plate and sigma by 2 epsilon naught due to this plate, both of them will add and will get sigma by epsilon naught.
So that's what we studied.
I thought recently I taught conductor, right?
No, you taught me yesterday that the conducting plate is combination of two non-conducting plates.
But there is a bit difference is there. There actually on the same plate you will have
Where it flows.
on the two charges. On the same plate you will have two charges, one side and other side.
And it will flow on the same side.
Because positive charge will always be away. Inside the conductor, you have to have zero. That means they both should be equal and opposite. At this point, at least inside.
But
Outside,
from this end also it will flow in same direction, na?
and from this end also it will flow in same direction.
Then how come it has become sigma by 2 epsilon naught?
No.
Due to one plate sigma by 2 epsilon naught.
This plate is due to this plate, red lines I'm drawing. There will be sigma by 2 epsilon naught here. Due to this plate, again they will be following like this. That is also sigma by 2 epsilon naught.
Hmm.
Now you can ask me what will happen. So from this plate, charge field will be away. So due to that second plate, I am drawing this field, and due to first plate, if I draw a field,
The first plate you have drawn, na?
draw. So this will become net zero because
Uh,
black line should be equal to red lines in between the conductor. Outside the conductor, here sigma by epsilon will be there. Here sigma by epsilon will be there.
hmm.
Okay. So now Q, electric field is equal to sigma by epsilon naught. That is Q by A epsilon naught. Potential difference is we need to write. Potential difference is equal to what? You know that ED is the potential difference if
E is equal to ED.
uniform electric field is there. Otherwise, you have to integrate.
It's only for parallel plate capacitor, na?
So otherwise, you need to so integrate E dot dr. Here, so if E is coming outside, integral dr will become R initial to R final. That means E into R final minus R initial. That means E into D is the answer. Okay.
Uh,
Uh, you might remember potential is equal to minus integral E dot dr minus. But actually here higher minus lower I am drawing as ED.
hmm.
Will be higher and this will be lower. So from here if you do potential will decrease. That is how much ED will decrease. So that means potential drop will be minus ED like this we will write. But this potential will be at a higher potential ED than this one.
Hmm.
So ED is potential difference. Then Q is equal to what?
Or we can write Q upon A epsilon naught into D.
So what we need to write is Q upon delta V we need to write. Okay.
Hmm.
Q upon delta V we need to write. So how can we write Q upon delta V? I will write it as Q upon delta V. Okay. Delta V can be written as E into D. Delta V is equal to E is what? Tell me. Q by
A epsilon naught.
into D, right?
Hmm.
You see this. Uh, I need to write in the form of what? Q by delta V, right?
Q by
Delta V, because this you see the formula, main formula. Q by V.
क्या है लिखना क्या है what we
Capacitor
have
Q by V, right?
hmm.
V is potential difference here.
So we have to find capacitance.
Capacitance. So Q by V we need to write.
So A epsilon naught by D.
Q by delta V, that is potential difference between higher plate minus lower plate, is equal to A epsilon naught by D. This is the 5-star formula for your parallel plate capacitor. The capacitance will be A epsilon naught by D. But in case if you induce electric medium in between them, that capacitance will become K epsilon naught A by D.
Hmm?
If induced electric medium between
Hmm.
capacitor, that will become K epsilon naught A by D. The capacitance will increase. You see the formula A and D are geometrical
We
parameters.
can directly write epsilon na.
Uh, Epsilon you can write, but I am trying to show it is Kc naught. It will become K into C naught is
Sir, on in that previous lesson you have given one relation.
you can write epsilon A by D, but by writing in this way, what you will know, it will depend upon the uh,
No, no, the relation was ki E E is equal to epsilon naught K.
uh, we can write E there.
What is E? E is electric field.
No, E is that E is permittivity of that medium.
And what is K? Dielectric constant of that medium.
Delta constant of that medium.
So we can write epsilon is equal to epsilon naught epsilon R na.
That epsilon R is nothing but K, delta constant.
Dielectric constant. So if force is 1 by 4 pi epsilon naught Q1 Q2 by R square, And if dielectric epsilon r is introduced,
Hmm.
we can directly multiply the dielectric constant in denominator. Na?
Dielectric constant in denominator. Force will become F by K.
F by epsilon r.
Epsilon R.
ठीक है, I got.
Net force will become, okay? You got this? This
हाँ.
C is equal to Kc not as well. Okay.
Hmm.
Now, if you go to spherical capacitor, so everywhere what you need to write V plus V minus V minus, we need to write potential difference between the positive plate and negative plate. And then what we can do is Q by V if you arrange.
Hmm.
Then you get the answer. So spherical capacitor, there will be positive charge. Now, V inside, what is the inside potential? Tell me. A Q by this is R1 and this is R2. I'll write it as A or B also. A Q by A,
V inside is Q by.
Q by A, B inside means due to this sphere. Okay. Shell means KQ by A, right? Hello, Neil, did I miss you? Neil,
Yes sir.
B inside is
Yes sir, I got it.
there will be due to two spheres. This is one, this is two. One is due to KQ by A plus other one should be equal to uh, K into minus Q by B. Do you accept this or not?
Hmm.
Huh?
Yes sir.
Then V outside, at the outside sphere will be KQ by B plus K into minus Q by B. Do you accept this or not?
V
KQ by
AQ
B.
by A चाहिए ना first case.
First case, due to this sphere at the outermost shell, what will be there?
हाँ, KQ by B ही होगा. ठीक है.
ये ऐसे क्वेश्चंस पूछेगा कभी गलत नहीं
So it is becoming 0.
So difference will become what? That plus minus V plus minus V minus potential difference is how much? K
0.
by, no, this one is there, right? KQ by A minus KQ by B. This will be the difference, right?
But at outside point it's becoming 0. Huh?
Yes, difference between inside shell and outside shell we need to do. That is the potential difference between the two plates we did, right? V plus minus V minus. So difference should be 0. So sorry, difference should be the potential difference.
Mm-hmm.
This plate potential you wrote, this place potential you wrote, the difference you found out. Here, outside plate we know it is 0, inside plate we know this much is the value. Difference between the positive plate and negative plate is this much only, right?
Mm.
So if you have 100 rupees, other has 0 rupees, the difference is 100.
Mm.
That means 100 minus 0 is the answer. So potential difference is what? KQ by A minus KQ by B. So then if I want to write it in the form of Q by delta V, so I will write it as, if I have to write in this form of, then Q I will take common, K by A minus K by B is equal to delta V. Then Q into K if I take common, A B minus A by AB is equal to delta V. So we have to write it as delta V, Q by delta V, right?
Mm.
Q by delta V is equal to AB by B minus A divided by 1 by K. That means answer will be K is what? 1 by 4 pi epsilon naught, right?
Mm.
So 4 pi epsilon naught AB by B minus A will be the option. You might check the option in your book.
It's not given in book.
देता है, carefully check कर, 2-3 पेज turn करो. अभी तक capacity देता जा रहा है. R1 R2 by R1 R2 minus R1 देगा. दिया?
Yeah. 4 pi epsilon naught
You understood how I did it? 4 pi epsilon naught.
AB upon B minus A.
If the electric medium is induced between them, it will become 4 pi epsilon naught into K. The K is dielectric constant. That is ER into AB by B minus A. Okay. Similarly, I'm not deriving now because that's not required for you, at least for NEET. But means also you don't need to understand much here. Just I made you solve so that you will be able to understand how I'm writing this capacitance. Deriving. This will be
So cylindrical capacitor is not given.
it's not given. Otherwise, capacitance you just write 2
Only parallel plate and spherical.
ln B by A. C is equal to 2 epsilon naught L ln B by A. Okay. Next, so the point is this is B, this is A. The second another important point is for spherical capacitor, one plate is here only, suppose of A, and other plate is at infinite. Infinite means the second conductor we consider it as infinite, that is infinite place. Only one will be there. So you take an infinite sphere of radius infinite, B is equal to infinite, and solve the problem. You will get one answer. Tell me carefully.
Yeah, I didn't get it.
Two spheres are there, right? Concentric shells.
Hmm.
Suppose only one sphere they will give and ask you to find out what is the capacitance. Only one sphere, single sphere.
C is equal to Q by V.
But second sphere you consider it as at infinite because you need to write potential difference right between the first plate and second plate.
So
So you keep
Q by V. V होगा तो V is equal to KQ by R ऊपर जाएगा.
तो इसका कुछ नहीं करना, मैं आपको शॉर्टकट बता देता हूँ, डेरिवेशन नहीं कर रहा हूँ, सिंपल. तो के क्यू बाई आर होगा आपके हिसाब से. फाइनली जीरो है कहा, इनफाइनाइट में जीरो है, तो इनफाइनाइट में पोटेंशियल कितना है, जीरो ही ना. तो के क्यू बाई आर माइनस जीरो इज द पोटेंशियल डिफरेंस. गॉट इट?
नहीं, पोटेंशियल डिफरेंस तो जीरो होगा. के क्यू बाय आर माइनस जीरो.
तो क्यू बाई डेल्टा वी इज इक्वल टू क्यू बाई के क्यू बाई आर, राइट? So Q gets cancelled. R by K. 1 by K is nothing but 1 by 4 pi. Answer will be 4 pi epsilon naught into R. Got it? This is the answer. Suppose if delta medium is there, we'll write 4 pi epsilon naught epsilon R into R. Okay. But another way also you can write. If you remember this formula, what I will do, I'll send AB to denominator. Okay. If a denominator, what will happen? So you will get it as 4 pi epsilon naught into B by AB minus A by AB, right? Right? This will be B gets cancelled. B is very infinite. That means can I consider this A is very small? A by AB is 0. So you see what is it left? 1 by A it is left, right? 1 by A, if it goes upside, it will become what? 4 epsilon naught A, that is nothing but radius of that sphere, right? 4 epsilon naught R. But then generally, टोटल चार्ज कितना है कैपेसिटर पे? सपोज यू सी दिस इज द पॉजिटिव चार्ज, this is the negative charge. So entire capacitor, what is the charge now? Zero, right? This is plus Q, this is minus Q, right? But whenever in question, if they mention this is a charge on the capacitor, that is nothing but charge on one plate. Got it?
Hmm.
But it is evident that net charge might be zero, but when it is indicating charge on capacitor is nothing but one plate charge you will take.
Hmm.
Magnitude of charge on one plate. Then electrostatic potential energy of capacitor. I'm not deriving here, just I'm giving the value. That is U is equal to Q square by 2C, very important formulas. Half C V square is equal to half Q. When do we need to write this potential energy formulas? Suppose uh, if you know battery is not connected, if battery is connected to the capacitor, potential energy across the capacitor will be maintained constant. At that time, you can use this formula half C V square. Okay, because suppose I'm considering this I taught you in the last also. Matlab one day you called me in phone and asked me analysis, if you would ever remember.
If capacitor is kept across a battery, मतलब battery is connected across a capacitor, potential difference will be maintained constant. And if battery is removed, charge will remain constant.
If battery is removed, there's nothing to give charge to this capacitor.
So formula will be Q square by 2C.
Q square by
2C will be applied, na?
So there in that kind of cases, you need to understand Q square by 2C. So like this, according to the situation, you can use these formulas. Yeah. This formula is जो भी है वो सब capacitor के लिए valid है. We generally derive it for the parallel plate capacitor, but it is valid. Then force between the plates of parallel plate capacitor.
F is equal to EQ डालेंगे. E is equal to epsilon naught dA by D. No?
What we need to write here, only due to one plate we need to write now for finding out force. Okay. Only one plate we need to use right now. The actual electric field is nothing but what? Q by A epsilon naught, right? That is sigma by epsilon naught. Right? But now what we were trying to find out, force between these two plates means what? How much force this plate is exerting on this plate, right? Into that EQ, Q of this plate. Are you getting this? So whatever force this is exerting on this plate and EQ, if you apply, you will get the force, right? No, I'll tell you. So there you are telling sigma by epsilon naught is a electric field at this point. Got it? Due to this, both the plates. Because this will become sigma by 2 epsilon naught. This will become sigma by 2 epsilon naught. Both will get added up at this point because both are in the same direction. So that is why it will become sigma by 2 epsilon, sigma by epsilon naught. Did you understand this point when I taught you in the previous? Now I want to find out force between the two plates means what you need to understand how much force is exerted by this first plate on second plate into the charge on this second plate. Do you accept this? The first plate, how much force is it exerting? Sigma by 2 epsilon naught, right? Only first plate. into charge on the second.
Sigma by 2 epsilon naught is electric field, it's not force.
That is field. Field into charge. If you multiply minus q on this second plate, you will get the answer, right?
Hmm.
So what is sigma here? Q by A.
Hmm.
Q by 2A epsilon naught into minus Q. The force will be minus Q square by 2A epsilon naught. This will be the answer.
Hmm.
I'm considering here D is much smaller than A area for this approximation. So Q square by 2A epsilon naught is the answer. So now this is minus symbol indicating that is attractive force. Okay.
Hmm.
So second plate will also attract first plate will also attract second plate. That force formula can also be written as minus q square by 2 epsilon naught, that can also be written as q square by 2cd, can also be written as energy by distance. These are the formulas that you can use. Force
Hmm.
between energy between.
बस आज इतना ही करेंगे.